This lesson is going to cover Unit 5, Day 1 of Section 5.1. So here we go, diving into more trig, and we're going to specifically talk about trig identities today, the foundational functions. So in the past, when we spoke of tangent function, tan theta, we would use the variables y over x to remind us that the y and x coordinates were to be divided on the unit circle to figure out the tangent of a respective angle. We're going to move off from using these definitions, where we're going to define tangent theta as sine theta over cosine theta. And as you recall, the y coordinate was assigned the sine of an angle, and the x coordinate was assigned the cosine of an angle. Since cosecant is the reciprocal of sine, which was the reciprocal of y, my apologies, we know that then cosecant is going to be the reciprocal of sine. Tangent and cotangent are reciprocals of one another. Y over x was x over y. We are going to reassign it now as cosine theta over sine theta. Secant is the reciprocal of cosine, or 1 over x. But let's, for this unit, use 1 over cosine. So here are four formulas that you'll be using quite consistently. Specifically, these, though, are the ones that are going to be used the most when it comes to tangent and cotangent. The Pythagorean identity is going to base itself on this equation here, x squared plus y squared equals 1, where Pythagorean theorem tells us that the sum of the legs squared is going to equal the hypotenuse squared. This is coming from our unit circle analysis. Remember when we constructed the unit circle and I asked you guys to help me find the coordinates of a respective point on the unit circle? Well, what we would do is we would calculate what the x distance was and then the y distance, and we knew that this distance here, being that it's the radius of the unit circle, is going to be a 1 unit in length. So if you apply the Pythagorean theorem to this idea, you would get x squared plus y squared equals 1 squared. So that's where this is coming from. So instead of us using the x and the y, we're going to substitute x with cosine squared theta. We're going to substitute the y with the trig function sine, so it's going to be sine squared theta equals 1. So here is our first Pythagorean identity. Okay, and I'm going to put number 1 because it's the first one we're learning, but also because it is where the other ones come from as well. The other two. There are 3 of them, by the way. Okay, so this is the first of the 3 trig identities. So one thing I want you guys to know is that just because the trig identity is written in this format, it doesn't force us to only use it in this format. And what do I mean by that? Well, it's going to be able to be manipulated. So for instance, if I specifically only wanted to solve for cosine squared, so I'm going to rewrite my function here, cosine squared theta plus sine squared theta. If I wanted us to solve for cosine squared, what I'm saying is on the left side of this equal sign, I just want the cosine squared term alone being solved for, isolated. So this sine squared has to move. Well, using my algebra solving skills, I know if I subtract sine squared on this side, I need to subtract sine squared theta on this side as well. So cosine squared comes down, plus and minus sine squared theta become a 0, and 1 minus sine squared theta stays on the other side. So now cosine squared is isolated. It's solved for. In that same manner, sine squared, if I wanted to solve for sine squared, well, I would do what to both sides? Well, cosine squared subtracted on this side, subtracted on this side. So sine squared theta would equal 1 minus cosine squared theta. So both of these equations are just being manipulated to be solved for a specific trig function that we want to use. So notice we can manipulate our Pythagorean trig identities. Okay, because as I mentioned, we have more than one. So what I did here in this example, we can also do with the other two. Okay, so this is still this equation, this is still this equation, just the terms are rewritten. So let's look and see how this applies with our second Pythagorean identity. So let's first find our second Pythagorean identity, and the way we would do that is take the original Pythagorean identity here and divide every single one of those terms by cosine squared theta. So I'm going to divide this by cosine squared theta. I'm going to divide this one and this one. I'm going to kind of put it sideways there for space. Okay, so whatever I do on one side, I must do on the other side. Cosine squared divided by cosine squared. I know you guys are going to be tempted to do this, okay, and say cancel, but my fear is when you guys say cancel, you say 0. Cosine squared theta over cosine squared theta is a 1 plus sine squared over cosine squared. Well, we already established, if I move up here to my formula chart, that sine over cosine is tangent. So if I do sine squared over cosine squared, that's going to be tangent squared theta. So I'm going to come down here and replace sine squared over cosine squared with tangent squared theta equals, I'm going to go back upstairs again, 1 over cosine squared. Go back up here. 1 over cosine is secant, so 1 over cosine squared is secant squared. So coming back up here, secant squared. So here is our second trig identity. So again, I'm going to highlight to make sure it pops out. And you will see in the following example that they're asking you to solve for tangent squared theta. The same notion of this equation can be manipulated follows. Okay, so if I want to solve for tangent squared theta, here's my equal sign, and I need this one to move over to this side, so that tangent squared is all by its lonesome self. So I need to subtract 1 to both sides. So if I subtract 1 here and I subtract 1 here, the tangent squared is going to be isolated, and the secant squared gets some company because the 1 on the left hand side moved over to the right hand side. So we are literally just moving over, hopping over the equal sign. The 1 becomes a -1 on this side. Over here, if you notice, when we solved for sine squared, the cosine squared jumped over the equal sign, became negative cosine squared. If I was solving for cosine squared, which was this one, the sine squared left the left-hand side, came over to the other side, and changed sign. So anytime you jump over that equal sign, so to speak, you will switch the operation from plus to minus or minus to plus. The third Pythagorean identity is found by taking that original number 1 identity now and dividing every single term by sine squared. So at this point in time, how about you pausing your video, doing this and this section on your own, and then unpause and look at my answers. Okay, so you are back. Hopefully you did take the time to pause. And You should have divided everything by sine squared. Again, you are going to get these terms from the top of your page. The cosine squared divided by sine squared, if you look upstairs, it's going to be a cotangent squared theta. So I'll come over here to my right, cotangent squared theta. My sine squared over sine squared reduces to a 1. Okay, because that's like saying a number, a value over another value. So like 5 divided by 5 is 1, or 10 divided by 10. Pi divided by pi, those are identical, so you get a 1. And then 1 over sine squared, again, you are still looking upstairs until you get more accustomed. So 1 over sine squared will give me cosecant squared theta. Make sure also, you will notice that you will start accidentally dropping the theta symbol. By the way, just in case you guys forget what that is called, it's called a theta. Make sure you guys always write it after your 3-letter trig function. Okay? So here, my dears, is the third Pythagorean identity. Here we go. Okay. And if you did manipulate it to solve for cotangent squared, you knew that in order for cotangent squared to be all by itself, this positive 1 needs to leave, and it goes over, changes sign as it jumps over that equal sign. So cotangent squared theta is going to equal the cosecant squared theta that's on the other side, and the minus 1 that joined it from the left-hand side. Again, this can be manipulated for whatever you wanted. So if I wanted to solve for 1, this cotangent squared will go over to the other side, and it would be cosecant squared theta minus cotangent squared theta. You can move around whatever term you want. Let's finish off this page here. This last bit at the bottom of your page is just reminding us that you can also rewrite your trig functions in this manner. So let's write these out first, and then I will kind of shift the page back and forth with the top so you can see what I'm talking about. So write that out. So here's what I'm talking about, okay? So upstairs, I'm going to shift this down a second. Okay, I had said cosecant is equal to 1 over sine theta, okay? Then I come down here, and now I'm saying sine is equal to 1 over cosecant theta. What I'm trying to get you guys to understand is that the trig functions are reciprocals of one another. This numerical notation right here, 1 divided by cosecant theta, merely means is the reciprocal of. So if I wrote the sentence for this equation, I would say sine theta is the reciprocal of cosecant theta. Okay, so sine is the reciprocal of cosecant theta, and if I read this one up here, cosecant is the reciprocal of sine theta. Secant is the reciprocal of cosine theta. Okay, so they are interchangeable is what I'm saying. So please note, if I write sine is 1 over cosecant, I can also say cosecant is 1 over sine. That's what I'm trying to get at. So this whole first page that we just covered is actually a summary of what your formula chart that will be given to you is. And the formula chart is all covered and condensed into this one page. So notice that here, highlighted 1, 2, 3, are the 3 Pythagorean identities that we just worked with on the first page. And you're going to notice that these to the right are the manipulated versions of these three functions. So for instance, if I wanted to solve for sine squared, cosine squared went over and became negative. If I was solving for tangent squared, right here, the 1 went over, became negative 1. So these here are just the manipulated versions of these, okay? Just some examples. These right here are all the ones covered at the top of your page and at the bottom of your page, okay? Now here's the one thing I want you to pay close attention to, okay? You see this sine theta and this cosine theta when it's equals to the reciprocals? You won't use these as much as you would use these right here, okay? And then this one and this one right here, the ones that have sine and cosine in them, you will use these a lot more than you will use these. So keep that in mind. So here's how these formulas are going to be used. So let's start off with number 1, example number 1. We have tangent theta times cosine theta. We are going to rewrite these expressions in terms of a single trig identity or a constant. So we're trying to condense as much as we can the given expression that's been given to us, okay? Simplify. We're trying to simplify, as a matter of fact, okay? Make more simple. So tangent times cosine. Now, if you see a cosine or a sine, leave it alone. That's why I'm putting a check mark at it. Leave it alone. It's very, very rare that you would take a cosine like this and rewrite it into 1 over secant. So if you see cosine, don't touch it. Do not change it into 1 over secant. It's quite rare that you need to do so. Tangent, let's change it. Tangent needs to always be rewritten. Well, I say always, almost always. So tangent is sine theta over, sine theta over cosine theta. So I got that from right here. So I'm replacing, substituting tangent theta with the expression sine theta over cosine theta. And this cosine theta is going to come back. I'm not going to do anything with it, okay? So I'm multiplying this times this, which in essence is actually cosine theta over 1 if you think about it. Since this is numerator and this is denominator value, they become a 1. Cosine theta divided by cosine theta is a 1. And sine theta times a 1 is just a sine theta. So this is my answer. It is a single trig identity. I am done. Let's try part B. 1 minus cosine squared theta over cosine squared theta. Anytime you have 1 minus or 1 plus, it's going to come from this section. All the 1 minus and 1 pluses come from this section. So 1 minus cosine squared theta is right here. That is equal to sine squared theta. So notice I have 2 terms, and I'm bringing it from 2 terms to 1 term. I'm condensing it. I'm simplifying it, okay? So 1 minus cosine squared theta is rewritten as sine squared theta. Cosine squared theta, I am not going to replace cosine squared theta with 1 minus sine squared theta because this is 1 term. I don't want to go from 1 to 2 terms. Remember, I am simplifying. Cosine squared theta, don't touch it. The simpler, the better. That should be like an aha moment. I've seen that formula somewhere. Sine over cosine. Where have I seen it before? I saw it right over here. But wait a minute. These have 2's and these don't. So what do I do? Well, I can still manipulate this equation. Sine squared over cosine squared means both of these had a 2. So therefore, this has to have a 2. And I'm down to a single term. Box it in because you're done. Let's go to part C. Cosine theta times cosecant theta. Cosine, we're happy with that. Leave it alone. Bring down the cosine theta. Times cosecant theta. Well, look back upstairs. Cosecant theta is 1 over sine theta. So 1 over sine theta becomes here. So again, this is like saying over 1. So there's nothing to cancel, so I'm just going to straight multiply my trig functions. Cosine theta times 1 is a cosine theta. A 1 times a sine theta is a sine theta. And I know this, if I look upstairs, cosine over sine theta is going to be cotangent theta. And so I convert a 2 trig function term rational into 1 term. There's my cotangent theta. Sine theta, we like sine and cosine. We are not going to change that. So check mark on that, keep it as is. So I'm going to write sine theta. Secant theta, you look upstairs, secant theta is the reciprocal of cosine. So I'm going to write times 1 over cosine theta. And you can put a little placeholder here to help you. I'm going to put my division symbol. Now this division symbol is this one right here, okay? Just so you're wondering. Because sine was this one, secant is this one, tangent is sine over cosine. Sine theta over cosine theta. Okay, so nothing to cancel, so I'm going to do sine theta times 1. 1 times cosine theta. And then here's my division symbol. There's that sine over cosine. Well, if you notice, these here are identical to these. And when you have two identical values dividing by each other, that's just a 1. Okay? And there you have it. Pretty straightforward. So let's go here to example number 2. So example number 2, we're going to take a pause at trig functions, but I wanted to draw your attention to the fact that the way you work with stacked fractions, when it's just numerical values, the rule still rolls over into trig function simplification of stacked fractions, okay? So this is a stacked fraction, okay? And with stacked fractions, when we are simplifying them to find the final value, what we do is we take the upper value or the upper fraction and we multiply by the reciprocal. This is something that you guys tend to recall in middle school as the, I'll write it over here, the keep, change, flip method. I hear that very often out of your mouths. So I write that there to kind of help you remember what I would prefer you saying, multiply by the reciprocal. But if this helps you remember, use it. So what do I mean by that? Well, you're going to take this fraction, the 2 over 3, okay, and you are going to change this bar, that's your division bar, into a multiplication. And the 4 over 15 is going to become the reciprocal. Okay? So you, in the words you guys like to use, keep the fraction above the bar as you see it. You change the division symbol to a multiplication. Flip, meaning take the reciprocal of the bottom. Once you do that, you are just multiplying, okay? And if you need to reduce, okay, you could cross reduce as well if you prefer doing it right off the bat. We do it in pencil here. Some students like to cross reduce, divide both of these by the common factor, so it's 3, so divide this by 3, divide this by 3. 2 and 4 have a common factor of 2, divide this by 2, divide this by 2. 1 times 5 is 5, 1 times 2 is 2. So whatever you want to do. But anyway, the whole point of this section here is getting you guys to understand multiplying by the reciprocal. Okay, so I'm not going to use up our time doing these other ones. Here's how this applies to our last set of problems. Okay, so again, we have the formulas at the top of our page, and you will continuously refer to those. So here we go. Cosecant theta over cotangent theta. So we still rewrite as we've been doing. Cosecant theta, you look upstairs, cosecant is the same as 1 over sine theta. Okay, that's this piece right here. Then I have a division bar, and I'm going to make that division bar really loud or pronounced for a point. And then cotangent theta, we look upstairs, is cosine over sine. Cosine theta over sine theta. So I want you guys to notice we have a stacked fraction. Fraction over another fraction. So we are going to hold on to that upper value, the 1 over sine, write it as you see it. My darkened division symbol becomes the darkened multiplication symbol, the keep change, and then the interchanging of the numerator and the denominator, which is the reciprocal status that we talk about. And now once you've done that, you will see that in this scenario you have a numerator and a denominator value that are identical over multiplication. Therefore, it allows us to cancel. You can only cancel over multiplication, okay? If this was a plus sign, no way, you can't do that, all right? So we're left with a 1. We're left with a cosine in the denominator. But if you look upstairs, 1 over cosine, upper right-hand corner of that formula chart, tells us that our answer is a, what did I do? Yeah, secant. Sorry, I got lost here. Yeah, I was looking at the wrong page. Secant theta. Okay. There we go. Single trig function. Let's go over here. 1 minus cosine squared theta. 1 minus cosine squared theta is one of our manipulated trig identities. Let me move this down here a little bit here. Here's my 1 minus cosine squared theta. So I'm going to replace this 2 terms with 1 term. Sine squared theta. My tangent squared theta is going to be this one or this one. But remember, I told you guys, don't use this one very often. Use the ones that have sine and cosine. So my tangent squared theta is going to be sine squared over cosine squared. Okay? Now I'm going to pronounce this right here, because I know this is the one to remind me that this is the one that I'm going to change. That's going to be sine squared theta over cosine squared theta. Yeah, I'm going to make this a little longer. Okay? So I do that to help you remember the key change flip notion. Okay, so we're going to keep the upper value above the darkened bar, change the darkened bar, and then flip the fraction below the darkened bar. So this becomes there, and that becomes there. So notice how I flipped him. So now, again, there's an invisible 1 right here that I can kind of put in there to help me realize that my numerator and denominator are identical over multiplication, so the canceling was allowed. Cosine squared theta boxed in for our final answer. Okay? All right, second to last problem, part C. Cosine theta times secant theta over tangent theta. I suggest that you pause the video here and work this on your own and then come back to me, okay? Okay, so you're back. Now, as I start this, I do want you guys to understand that when you guys are doing the simplifications of all these trig functions, note, please, that there are several approaches that you can take sometimes. So just because one student starts out one way doesn't mean their way is the only way, okay? You all arrive to the final same answer, or should, but the approaches to the way you simplify may differ. So let's go. Here's what I think the majority of you guys probably did. Cosine, you kept it the same. So cosine theta. Notice I'm still writing my thetas. Secant, we want to kind of change that. So a little frowny face. Let's change secant to reciprocal of cosine. Now I put my darkened bar to make it a point that this is a stacked fraction. So, and tangent I'm going to rewrite as sine theta over cosine theta. Now maybe you didn't change it immediately. Maybe you left it as tangent theta, okay? Now once you did that, you saw this is like a over 1. You knew that over multiplication, since these are multiplying, you can cancel. So you were left with a 1 upstairs over sine over cosine, which means you are going to multiply by the reciprocal. So I keep the 1 and I change, which is this. Let me kind of move my paper up here. I change to the reciprocal of cosine over sine. Now 1 times cosine over sine is just cosine over sine, but cosine over sine we know is cotangent theta. So there's your answer. Okay? But here's what I wanted to bring your attention to, that there are different approaches. So a little, let's put it here at the top. Something I want you guys to know this. If you have sine and you multiply it by its reciprocal, okay, which is cosecant. Remember, cosecant is 1 over sine. The multiplication of a trig function by its reciprocal will yield a 1. So if I multiply cosine by its reciprocal and tangent by its reciprocal, you will always get a 1 value, okay? And just numerically, what I mean by that is, if I multiply a number 3 by 1/3, that's going to be 3 over 3, which is 1. If I multiply a 1/10 by a 10, that's just going to be 10 over 10, which is a 1. So any number times the reciprocal of that number will always be 1. That's what this is. So if you remember the paired up reciprocals, you will save yourself some time, such in this problem right now that I'm going to show you. Cosine and secant are reciprocals of one another. So if you knew that trick, that is just a 1 over, that's my tangent, I'll just bring it over, and 1 over tangent, look at your formula sheet, is cotangent theta. And you're done. So you would save yourself all this work here, which is fabulous work, to really like a step and a half. So always remember that these here, they are reciprocals of one another. Reciprocals of one another. If you have reciprocals of one another that are multiplying, you will get a 1. Okay? If you multiply them by each other. So keep that little trick in mind. And again, this is just 2 ways of starting it. Some students, like I said, you would have done this. If you kept this as tangent, it would have been 1 over tangent, which then would have saved you writing that, and you could have just said cotangent from there. So there's so many ways. Okay, let's do this last one so that you guys can get to working on that homework. So sine theta comes over. We like sine and cosine. I'm going to make this more pronounced. This is my main division bar. And then cosecant is 1 over sine theta. Again, don't forget to write your thetas. Multiply by the reciprocal. Keep the numerator. Change the division bar. Reciprocal, flip, however is the conversation in your head. So this is also over 1. So sine times sine is a sine squared theta over 1, which is just sine squared theta. So you don't even have to really write that step if you don't want to. I'm just, for note purposes, writing it out for you. Okay? So those are the basic beginning of simplifications of trig functions, and those should help you with the homework that you have on this side. So work out these problems and check your answers against the answer key provided. I do want to do one last thing. I do have students that are not really pronouncing these trig functions correctly. For instance, they're saying sec or cot. So on this front side of your paper, please write out the pronunciations of your trig functions. So this first one, you can read it as tangent theta or tan theta. CSC, I need you to be able to read it as cosecant theta. That's what CSC stands for. COT is not cot, it is cotangent. And SEC is not sec or sec, it is secant. All right, this here, I love this one. You guys love to say sin. It is sine theta. Okay, and this one I rarely hear you guys say it wrong, cosine. So please remember, there's 3 words that have cosecant, cotangent, cosine, and then you have tangent, secant, sine. Okay? Thanks for watching, you guys. Good luck with the homework. I'm here if you need anything.